Hello and welcome everyone. This video is part 3 of the continuation series of SSL configuration for Apache Tomcat, and in today's session what we are going to discuss is creating a Java client application to communicate over SSL with Tomcat. Well, in the last two videos we discussed about SSL creating and generating a self-signed untrusted SSL certificates using the Java key tool that is provided as part of our JDK, and at the same time we have configured our Tomcat server with SSL, making necessary changes in the server.xml file. So let's today extend this a bit further and create a client application that can communicate with over SSL with this Tomcat server. So what exactly we need for this purpose? What all we need is nothing but this JSSE, Java Secure Socket Extension API, that was earlier in prior to 1.4 edition of JDK need to be integrated separately as it was available as a separate download. But now the good news is that after JDK 1.4 it is internally integrated in our JDK 1.4 later. This JSSE is integrated available with JDKs. Like let us you are using JDK 1.6 plus, it is having this JSSE pack available, you don't have to download it. Let me give you a brief description about what this JSSE is. It's a set of package, or what we call it API, that enables secure internet communications. It implements a Java technology version of SSL and TLS protocols. It includes functionality for data encryption, server authentication, managing integrity, message integrity, and optional client authentication also. Now let me tell you, beside this we have something called Java GSSS and SASL API also. Java GSS and SASL API too, but we are not going to discuss this, as the task of creating a client application in order to make it interact with Tomcat over SSL can be handled by using this JSSE. So we don't need any additional package or software to be installed over here. It comes pre-built and we are going to make use of it efficiently here to understand how this client application are going to work. And for that, let's start with here. Now first start the server and test our previously configured application whether it's running or not. So let me just check it. The application server, the web server, sorry, is Tomcat 7, I guess. It's here, cd bin, and let me say startup. Okay, so fine, the server get started and the port number here is 9090, the same we have used in the earlier session. So let me check it out. http://localhost 9090 and let's hit. Okay, so the Tomcat server is up and running, and at the same time, if you remember, in the last video we have learned how to configure the SSL. So SSL must be working over here. Let me change the protocol and the port number, default 18443. And if you get a response, definitely we got it over here. We continue to the website as a sign of warning that you are using unsigned certificate. Well, certificate here because it's not a trusted certificate, it's just dummy certificate we have generated for the testing purpose. Okay, fine. So I can say that my app server is up and running with SSL configured. Now let's jump into the coding part, build a client application that will communicate with our server with SSL. So all we need actually is like an ID simply, or you can even start typing in your favorite text editor, whatever you like, and the code will be the same. So I'm using here Eclipse, and what I need to do, let me just start with creating or building a project. So I'm gonna build quickly a Java project over here, this Java project. Let's name it SSL test client. Fine. Perspective need to be changed to Java perspective. This tutorial is not about Eclipse, so just ignore these things. What I'm doing in Eclipse, you can just open the editor and you can start typing in the code. Okay, so I got it. So first let me create a package here, com.wordpress.srkplanet. Next we need a class here, and let's name this class as SSL client. Let's have a main method in the class, and simply if you need to have a client application that need to invoke a server's resource, how you gonna do it? Let me increase the font, colors, font, basic, text, font, edit, just increasing the font to make it clearly visible to you. Fine, I think now it is visible quite. Okay, so as I was talking about, if you need to simply create an application, a Java application that need to invoke some server resource, what all you need to do? You need to import the java.net package, you need to make use of URL and URL connection classes, and just you making use of some stream readers, we can read line by line or character by character that whatever the response is going to be written from the server. But all I'm telling is import this java.net package. That is very common, and you have developed a lot of application like this. So, and of course the exception handling should be done first, because this kind of network related application, when you're creating, you might be going to face a lot of exceptions over here, and just I'm trying to print all the exception or error that we are going to get or receive in this application. One thing note here please, that never use this generic exception handling. Just for demonstration I'm using this exception class, the base class of all exception. You should in production generally or officially it's recommended to use a type of a kind of exception that is going to be raised over here. Never use this approach. It's just for demonstration that I use the base class exception over here. Okay, so all we need is a URL class, and that URL should be pointing to some resource using a URI. Like here I just copy this URL to save some time of typing it here, https localhost 8443. We got it. Okay, next what we need is URL connection. Let's say UC equals to new URL. Sorry, yeah, this is not going to work. You have to write URL object dot open connection. What it will do, this URL, now we just open the connection with this URL. It means the client application is going to point to a resource using this URL class, and we are asking this open connection method to open a connection from Java client to that server referring by this resource, referred by this resource name. Okay, now next what we do is simply we need to have some kind of readers, stream reader that can read the characters or the line which is being written as a result of this open connection statement. So I'm gonna make use of over here input stream reader class, and this input stream reader class is in java.io package that you need to import over here. Import java.io. Fine, this is our input stream reader, and what we need to pass over here is the URL connections get input stream method. Like I say here, URL connection object dot get input stream. So all it will do is this particular URL open connection that we got through this URL object will further call the get input stream method to get or receive all the bytes of information which is returned as a response of this open connection method. And when we have this input stream reader, we have this buffered reader over it which we can make use of to read this particular written data line by line or character by character as we wish. So let's have here buffered reader, let's say br new buffered reader, and here I pass the input stream reader object. Now let's say we have a string variable, call it temp, and while this variable temp is reading the bytes which is returned as a result of the response that we received over there, and we need to make a check over here till we reach to the last current content that is returned as a response of this particular URL. And this line, when it is getting read, what we need to do, let's say we have another variable over here, let's call it response, and let's store the result, keep on appending the result over here. In this case, whatever is being written, and it's being written by using the buffer reader object. Buffer reader reads the line by line whatever is written as a response to this connection opened, and then put a string that which has been written by the URL connection. And line by line, when it is reading it in a loop till we reach to the end, we need to append it to this particular response variable that is of string nature. And one more thing I would like to point over here, when you are referring to a web-based resource and there are a lot of character and huge page or specific resources are going to be written, using this approach will not be efficient. As you can see over here, this plus operation, the concatenation operation I am performing in a string, is not considered efficient. It has some performance issues, drawbacks, like whenever you concatenate two string, actually what happens in the backend, it create an object of a string builder and tries to invoke this concatenate operation. So every time, how many times the number of loop runs, every time it will create an object of a string builder and perform the concatenation. Rather than we should use a string builder or a string buffer, but that's not the topic we are going to discuss here. Just a recommendation from my side, and you should take care of it in your actual production code. Anyways, so we have got or receive all the data in the response object. Let's just print it. I say system out println whatever you got in response, and do not forget to close this buffer reader to save the resources. Fine. So right now this is the code. As you know, this is going to work in normal situation. Let's say we don't have HTTPS, we have a normal HTTP connection. Fine. And let me show you this code. Actually it works, and you might have tested this kind of codes or simple application that you have developed. And this is what the expected output you are going to receive over here is something you can see here. The output that is written from the server actually all comes in one line. The reason is I haven't used the new line character. At the end of the response, I should have added this /n new line character to represent it vertically rather than having all the content appended on the horizontal output. So this is what I was talking about. This is all the content that is written from the server as a result of invocation of simple index page or the home page of this server. When we refer to this URL, open connection method is invoked, and as a result of open connection URL connection object type is written. This handler further called input stream and returns an input stream handler which will be handled by Java input stream reader, which is further given to the buffer reader, which reads line by line whatever is written as a response of execution of this resource on the server. We have just iterated over it and stored the result, concatenated the result in a response type in a response variable named response name variable of a string nature, and we have appended a new line character to get the response as it is written by the server, and we have printed it on the console, and this is the output as expected. And as I said, the same can go with this HTTPS, like you can change this to HTTPS and make the port to 8443. But here's the problem: when you are trying to invoke specifically you are trying to access a resource from the server using this secure socket layer protocol, additional things need to be done over here. What additional things I am telling you, when you are going to execute it, you are going to experience some exceptions over here. That kind of exception, like it will say the path building failed exception, PKIX, the certification does not match, or kind of like, let me show you. Now I've changed this to HTTPS and trying to execute it. Look, this is what I'm talking about, SSL Handshake Exception. What it says, PKIX path building failed. What this PKIX is, public key infrastructure X.509 certificate it is referring to. Means your certificate, whatever you are looking for, is not found on the server. Unable to find valid certification path to requested target. Why it is claiming that? The reason is you don't have a signed certificate, a trusted certificate. You have a simple dummy certificate that is signed by yourself, and it is just generated in your machine. If you remember, while generating we specified our name, our organization name, our country code, and rest of the thing, and that certificate is not trusted. And the GRE, when it is going to Java runtime environment, is going to make a request to the server over this SSL, and it is requesting for a certificate to be presented by the server. That certificate which is written by the server is rejected by your GRE. Actually it was not signed and it's not trusted. So in order to make this work for the dummy certificates, we have something that we need to tell our GRE that forcefully, or you have to just point it to where exactly your certificate is stored in your machine, the trust store, and the password, as well as you have to tell the GRE this is my certificate. It's stored somewhere. If I remember, it was in C drive that we have stored or kept here. It's my cert.cert. This I need to point my GRE over there, and the password and rest of the information I need to supply, so that GRE can happily make use of that certificate and trust or authenticate our client. How we tell the GRE Java runtime environment where the certificate to be found? We need to pass this information to Java runtime environment as a command line argument to our application. You know how to pass this command line argument when executing Java application. You write Java that is the interpreter, followed by the application name, followed by whatever the argument you need to pass. But here, in case we are gonna use this specific IDE, I'm going to tell you the process. Right click on your class file, come to properties, you see here run debug settings. You can see your class over here, SSL client, that has been generated. The Java file is compiled into bytecode, and this is the class file that will be generated at runtime. Click on the edit button and come over here to the arguments. In the arguments section, you need to pass in an argument specifying making use of this java x.net.ssl package that has got trust store property, and I specify here the location of my certificate, that is my cert.cert. At the same time, another parameter is the password that you need to pass, java x.net.ssl.trust store password, and it is going to be srq123. If I'm not wrong, I have specified this password. Okay, let me just show you this on here if it is not visible in the video. This thing, this is all you need to pass. First in this -d java x.net.ssl.trust store, the location of your certificate in your local machine or your local certificate store, and then again -d java x.net.ssl.trust store password equals to whatever the password you have specified. So this is what I have given or supplied as a virtual machine argument to the Java runtime environment. Apply. Okay. So now if we run this time, you guess it will work? No. Additionally, one more thing you need to do. Let me tell you what happened when I specifically made GRE, forced our GRE to approve the GRE that this is the server is authenticated. The certificate I am presenting to you is of course not from your store, certificate store GRE, but it is from my local store. But you accept this connection and make this code to work. The thing is that it is gonna throw you some exception, again SSL Handshake Exception, stating that no name matching localhost found. What exactly this exception is, let me show you this time. Okay, so this is what I'm talking about. You check over here, no name matching localhost found. Kind of misleading exception message that is being generated. No name matching localhost. You see here, this is the localhost I specified. The server is up and running on localhost. There is no doubt over it. So why exactly it is complaining that no matching this particular certificate is found on this server? The reason is that it actually the problem with it is this, that the localhost we are requesting to establish this SSL based communication is not having a trusted signed certificate. You know this, and if you remember that we are actually using this self-signed untrusted certificate, and GRE is refusing the verification of this host name as a trusted source. As earlier we forced GRE to believe that our certificate is signed, but at the same time we need to tell the GRE that this server, this local host, I am referring to a local machine as a server on which my instance of Tomcat is running, is trusted one. It has to be verified by the GRE, and this verification again I have to implement over here, that I have to tell the GRE at runtime that this server you are trying to invoke this request this HTTPS based connection is verified one. And for the same, again we have a specific interface over here available in the java x.net.ssl package. As you can see here, java x.net.ssl, I made use of this two property in the same package, java x.net.ssl. In this package java x.net.ssl, I have an interface known as simply Hostname Verifier. This interface is having a method verify, and what actually this interface is doing, let me tell you first. This hostname verifier is a base interface for hostname verification. That is any application that is hosted on a server on a machine, and the name that you are trying to resolve while making the specific request for a specific kind of certificate based request. So what happened that during handshaking, if URL's hostname and the server's identification hostname mismatches, this verification mechanism can call back to implementer of this interface to determine if this connection should be allowed. And all we need to do here in simple word is to override the verify method available in this interface and explicitly return true, as in this case, from this verify method of this hostname verifier interface. Let me code this for you to give you an understanding of what I'm explaining here. First I will make an import here, java x.net.ssl, this package I'm talking about. Now let's create a separate method over here, okay, for this validation kind of thing. Like I say, my host verifier, okay, and here as I said there is an interface hostname verifier existing in this java x.net.ssl package. You need to have override the method verify available in this hostname verifier. Hostname verifier, and I say here hostname verifier anonymous script, anonymous class I'm generating. Okay, actually as I said, it's an interface, you cannot just instantiate it. Look over the code here. What I'm doing, I'm creating an anonymous class over here in order to reduce the complexity. I can create a class which will implement this hostname verifier. I will override this verify method, and as a result of this verify method I will force to return true from it, and then again I'm going to create an object of that class and make use of. Rather than reducing all those complexity, we have a technique over here of anonymous class available in JDK. I guess you know this, so just giving you making you understand things what this code I've just hit control space and generated in case of Eclipse. You can type in any editor also. This is the interface variable, and this what is a anonymous class. A class without a name is created and this will be created at runtime, and this class is implementing the hostname verifier, and in turn it is overriding the verify method. This verify method takes an argument of type string and SSL session. That is not of concern right now. Just you need to make over here is to ensure that this method verify method returns true. If it returns true, the next step that you are going to take over here is to make use of HTTPS URL connection. Abstract class HTTPS URL connection. This is an abstract class which offers you a method over here, set default hostname verifier, and you just pass your hostname verifier variable referencing to a class that has just overridden the verify method. This is all you need to do. This HTTPS URL connection is again available in java x.net.ssl package as an abstract class which has got this method set default hostname verifier. We are forcing over here set default hostname verifier for the JRE. We are saying to JRE this is the default hostname. As you have complained JRE that this no name matching localhost found, I am telling you this name localhost is verified hostname, and you should just take your request up to the server so that when the server returns you the certificate, we have specified you as a command line argument that this is the key store from where you have to match the certificate. You have to go for the authentication. We have supplied the password and everything to you. You just understand that this is a valid signed certificate. Of course it is not, and should never use this in production. Never use this approach. I'm just explaining you a kind of trick or thing you can say. This is available in Java that you can make use to test your own code and only for testing. You have this verification overdone forced to the JRE. Now all you need to do is that as it is a separate method, my host verifier, you need to invoke this host verifier over here. So as it's a non-static method, I have created over here public void my host verifier. I need to create an object of my class SSL client. I create an object of my class SSL client, s equals to new SSL client, and just say my host verifier. I invoke this method before establishing the connection to the server in using SSL, and if this is verified, and all you remember again, let me show you here in the command line argument, I have set this virtual machine argument for our key store location and key store password. So all this set, we are ready to go. Now just run it, Java application. Yes, you got it. See you. this request that you are receiving right now is a result of HTTPS communication that you are making via client-side Java application to the server. The same result you received over here. Look, again and again, HTTPS. And if you remove this verifier from here, see the result. What happens if I remove it? Again, you will be given or complained by JRE that host name is not the same as expected and is not trusted, kind of. Look, exception, no name matching localhost found. So the same technique that we use for invoking general URLs, we are making use of here, but as it's an SSL based communication you need to establish from client to server, you have to perform two additional steps over here. And these two additional steps is not that complicated, if you can see over here. And every time you are trying your code, testing your code, you have to follow this approach. Okay, and if it sounds a bit complicated to you, let me just summarize all the things that you need to do. Okay, so summary can be listed over here, is that create a key store for Tomcat using SSL, and for creating the key store what we use Java key tool. Okay, and second step what we did is configure Tomcat using server.xml file. If you remember, we have added a specific element in our service element. That element was nothing but a connector specifying, or as it was already available, we have uncommented it in order to make this configuration by Tomcat to be understood that SSL certificate is there somewhere in the local repository, and make use of it. Third step what we need to do is configuring our Java runtime environment, that is JRE, to authenticate the server's certificate by means of its local key store. Okay, what I'm saying is that we have passed some command line argument, if you remember, from the java x.net.ssl package, specifying the key store and the password for the key store. This is what the configuration for Java runtime we did to authenticate the server certificate and making point JRE to this local key store. But at the last thing that was very important over here is to create a method that will act as a hostname verifier. So this is all the summarized form of what you need to do in order to make SSL work in case of you are using client application to interact with your SSL based server, and you have your dummy certificate created. Especially if you have a signed certificate, you don't have to perform this third and fourth step. This third and fourth step, let me just do it here as an additional step. Why I'm saying is additional step over here, the step 3 and 4, cause this is not required in case you are having a signed or trusted certificate. Only if you are having unsigned, self-signed untrusted certificate generated by key tool just for the learning purpose or for the demonstration purpose, then you have to perform this 2 additional step. Okay, and as I said, if you have any doubt or query, do not forget to visit this specific my blog over here, srkplanet.wordpress.com, and this any kind of issue you are going to face, you can post over there. You can ask me anytime, I'm ready to answer. As well as you can download the source code of this application on pointing to this location. I will upload the complete code application over there on this server. Okay, so this is all we need to understand to create a simple Java application to interact with our SSL based servers. Thank you for watching.